Hello dear students, let us solve some numerical problems from electrical circuits in which we will solve the numerical problems from Kirchhoff's laws, principle of Wheatstone bridge, meter bridge, potentiometer and conversion of galvanometer into voltmeter and ammeter. The first question is EMF. The EMF of a battery is balanced by a length 75 cm on potentiometer wire, and the EMF of a standard cell of EMF 1.02 volt is balanced by a length 50 cm. Calculate the EMF of the battery. Solution to question 1 given. E1 is what? EMF of battery. For which balance length is 75 cm. For cell of EMF 1.02 volt, balance length is 50 cm. We have to find EMF of battery. Now for potentiometer, E1 upon E2 is equal to L1 upon L2, which gives E1 equal to E2 into L1 upon L2. Therefore, we get E1 is equal to 1.02 into 75 upon 50, which gives 1.53 volt. So, the EMF of battery will be 1.53 volt. Next question, number 2. The question is, a moving coil meter has resistance 25 ohm and gives full scale deflection for 4 milliampere current. How could this meter be converted into a meter which gives full scale deflection for a current of 50 milliampere? So, solution to question 2 given. For moving coil meter, moving coil galvanometer, current for full scale deflection is 4 milliampere and resistance of coil 25 ohms. To measure current I is equal to 50 milliampere for full scale deflection, how to convert? Solution: to measure current I greater than Ig, we must connect a shunt resistance S parallel with galvanometer. Where shunt has value Ig into G upon I minus Ig values are known. Ig is 4 milliampere, G is 25 ohm, I 50 milliampere minus Ig 4 milliampere, milliampere is common and cancels out, so we get 100 upon 46 ohm, which has 2.17 ohms. Next question number 3. The resistance of the coil of galvanometer is 9.36 ohms and gives full scale deflection for 0.0224 ampere current. The only shunt available has resistance 0.025 ohms. What resistance must be connected in series with the coil to measure 0 to 20 milliampere? Solution to question 3. Given, suppose this is galvanometer, resistance G, we have to connect resistance R, shunt resistance has value 0.025 ohms, we have to measure maximum current 20 ampere, Ig is 0.0224 ampere and G is 9.36 ohms. We have to calculate R. Solution: to measure I greater than Ig, shunt S is equal to Ig into G, but G is in series with this capital R, therefore total resistance will be G plus R, G plus R upon I minus Ig. This means that S is 0.025 is equal to Ig is 0.0224, G is 9.36 plus R is unknown upon I 20 minus 0.0224, which gives R is equal to 12.936 ohm, which is nearly 12.94 ohms. Next question number 4. Using Kirchhoff's rules in the given circuit, find I, R, E, and if the circuit is broken at point P, then current in resistance R. This is the given circuit in which we have to find the value of this, value of this, value of this. I is what, R is what, E is what, and if the current is broken at point P, then the current I dash flowing in resistance. Solution to question 4. For simplicity, suppose this is E1, this is R, sorry, I2, this is I1, this is R1, this is R2. For simplicity, suppose this is E1, this resistance is R1, this current is I1, this current is I2, this resistance is R2. This point is suppose Q. First, from Kirchhoff's current law at node or junction, Q, we get total incoming current is equal to total outgoing current. I1 is incoming current and I2 and I are outgoing current. Therefore, I1 will be equal to I2 plus I, which gives I as I1 minus I2, which is 6 minus 4 is equal to 2 ampere. So, this current I will be 2 ampere. Second part, in this outer part, this one, in the outer loop, KVL gives Kirchhoff's voltage law. Sigma EMF is equal to sigma IR. Sigma EMF is E1. E1 is equal to I1 R1 plus IR. I1 R1 plus IR. E1 is 28. I1 is 6. R1 is 3 plus I has been calculated 2 ampere and R is unknown. This gives 2R is equal to 28 minus 18, which gives R as 5 ohms. So, this resistance is 5 ohms. Third part, we have to find E. Suppose this is closed loop 1, this one is closed loop 1 and this is closed loop 2. In the closed loop, 2, Kirchhoff's voltage law gives sigma EMF is equal to sigma IR. Sigma EMF is E. E is equal to sigma IR. Sigma IR means I1 R1 plus I2 R2. I1 6, R1 3 plus I2 4 into 6 18 plus 24, which gives 42 volts. When the circuit is broken at point P, then the circuit becomes as in the following figure. Therefore, KVL in outer loop gives, therefore KVL in outer closed loop gives sigma EMF is equal to sigma IR. Sigma EMF is E1 is equal to I dash R1 plus I dash R, because R2 and E are passive, disconnected. So 28 is equal to I dash taken common, R1 plus R. R1 is 3 and R is 5, which gives I dash as 28 upon 8, that is 3.5 ampere. Next question number 5. A potentiometer wire is 10 meter long and has resistance 20 ohm. What is potential gradient if it is connected to a battery of 3 volt and a resistance of 10 ohms is connected? So, solution to question 5 given. Suppose this is potentiometer wire AB, this is accumulator B is equal to 3 volt, a resistance of 10 ohm is connected. Then we have to find the potential gradient. Solution. Here VAB is given to be RAB is 20 ohm, LAB is 10 meter. Potential gradient in wire will be equal to BAB upon LAB. BAB is I into RAB upon LAB. I is E upon R plus this R into RAB upon LAB. Values are known. E is 3, RAB is 20 upon R plus R is 10 and RAB is 20 into LAB is 10. So this comes to be 0.2 volt per meter. Next question number 6. What must be the EMF A in the given circuit to allow 1.8 ampere current to flow in 7 ohm resistance? Internal resistance of cells are negligible. This is the given resistance. For simplicity, suppose this is E1, this is R1, this is R2 and this is R. Suppose this is current I1, this is current I2 and this is node A. We have to find E. Solution to question 6. In this outer closed loop, in the outer closed loop, KVL gives sigma EMF is equal to sigma IR. E1 is equal to I1 R1 minus I1 R1 plus IR. E1 is equal to I1 R1 plus IR. Therefore, I1 will be equal to E1 minus IR upon R1 . E1 is 24 minus I is 1.8, R is 7 upon R1 is 3. So, I1 comes to be 3.8 ampere. At node A, Kirchhoff's current law gives at this point total incoming current is equal to total outgoing current. Incoming I1 plus I2, I1 plus I2 is equal to I, which gives I2 is equal to I minus I1. I is 1.8 and I1 is minus 3.8, which is minus 2 ampere. That is, the negative sign indicates that the current in this current I2 will be in opposite direction. This is closed loop 1 and this is closed loop 2. Now, in closed loop 2, KVL gives. In this closed loop, sigma EMF is equal to sigma IR. Sigma EMF means E is equal to I2R2 plus IR. I2 is minus 2, R2 is 2 plus I is 1.8 and R is 7. So, this is minus 4 plus 12.6, that is 8.6 volt. So, this EMF must have value 8.6 volt. Next, question number 7. The question is, a simple potentiometer circuit has uniform wire AB of length 1 meter and resistance 2 ohm. If the variable resistance R is given value 2.4 ohm, then what will be the length AC of wire to give null deflection in the galvanometer? Resistance of battery is negligible. This resistance R is given 2.4 ohm. Its internal resistance is 0. Internal resistance is 0. We have to find this length for null deflection in the galvanometer. So, given solution, given LAC is what? For null deflection. In galvanometer, L from A to B is 1 meter. Resistance from A to B is 2 ohm. Resistance R is given value 2.4 ohm. Solution. Resistance per unit length of wire will be equal to rho, which is RAB upon LAB, that is 2 ohm upon 1 meter, 2 ohm per meter. Now for null deflection in galvanometer, potential difference must be 0, that is V A to C must be equal to E. So V from A to C must be equal to E. VAC will be I into RAC. So I into RAC is equal to E is 1.5. I will be equal to V, this voltage, or suppose this is E1. So I will be equal to E1 upon RAB plus capital R plus internal resistance of cell. Internal resistance of cell is 0 into RAC will be equal to L A to C into resistance per unit length. This will be 1.5 meters or 4 divided by 2 ohm RAB plus 2.4 ohm plus 0 into LAC unknown into 2 ohm per cm will be equal to 1.5, which gives LAC is equal to 1.5 into 4.4 divided by 8, it is 6.6 upon 8, which gives 0.825 meter. 0.825 meter. Next question number 8. A battery of EMF 6 volt and internal resistance 0.5 ohm is connected in parallel with another battery of EMF 10 volt and internal resistance 1 ohm. The combination sends current in external resistance 12 ohm. Find the current in each battery. Solution to question 8. Solution to question 8 here given. This is cell of EMF E1, internal resistance R1, connected in parallel with another cell of EMF E2, internal resistance R2. This combination sends current to external resistance R is equal to 12 ohm. we have to find currents I1 and I2 passing from the cells. Suppose this is loop 1 and this is loop 2. This point is A, junction A. E1 is 6 volt, R1 is 0.5 ohm, E2 is 10 volt, R2 is 1 ohm. In closed loop 1, Kirchhoff's voltage law gives sigma EMF is equal to sigma IR, means E2 minus E1 is equal to I2 R2 minus I1 R1, both are opposite. R2 is 1 into I2, R1 is 0.5 into I1. So 4 is equal to I2 minus 0.5 I1, question number 1. And KCL in closed loop 2 gives sigma EMF is equal to sigma IR. Here E2 is equal to I2R2 plus I will be equal to I1 plus I2 from Kirchhoff's current law. So I into R. E2 is 10, R2 is 1, I2 plus I means I1 plus I2 into 12. So we get 10 is equal to 12, I2 plus I2 means 13, I2 plus 12, I1, equation 2. Solving questions 1 and 2, we get I1 is equal to 2.27 ampere, I2 is equal to 2.87 ampere. Next question number 9. The length of a potentiometer wire is 10 meter and a potential gradient of 0.0015 volt per cm appears in it due to steady current. Calculate balance length for a cell of EMF 1.018 volt. Second, unknown EMF E2 if balance length is 940 cm. Third, maximum measurable potential difference. Solution here given for potentiometer. Length of potentiometer wire is LAB is equal to 10 meter. Potential gradient is equal to, suppose potential gradient is equal to 0.0015 volt per cm. Therefore, potential gradient will be equal to 0.0015 volt upon 0.01 meter, which gives 0.15 volt per Newton. First part, E1 must be equal to potential gradient into L1. Therefore, L1 will be equal to E1 divided by potential gradient. E1 is 1.018, potential gradient is 0.15. So, L1 comes to be 6.79 meters. Second part, E2 will be equal to potential gradient into L2. Therefore, here L2 is 940 cm, that is 9.4 meter. Therefore, E2 will be equal to 0.15 into 9.4, which gives E2 as 1.41 meter. 1.41 meter. Third part, the maximum will be equal to potential gradient into L maximum. Potential gradient is 0.15 and L is 10. So, maximum measurable voltage will be 1.5 volts. Next question number 10. A voltmeter coil has resistance of 50 ohm and a resistor of 1.15 kilo ohm is connected in series. It can read a potential difference up to 12 volt. It can read potential difference up to 12 volts. If the same coil is used to measure current up to 10 ampere, what resistance of the shunt is required? So, solution to question 10. Given for galvanometer converted into voltmeter. G is 50 ohm resistance of coil of galvanometer. Series resistance connected 1.15 kilo ohm, which will be equal to 1.15 into 1000 ohm or 1150 ohm. B 12 volt, maximum measurable voltage by voltmeter 12 volt. Shunt should be how much? Shunt needed to convert galvanometer into ammeter of I is equal to 10 ampere. Solution for voltmeter. Series resistance R is equal to B minus Ig into capital G upon Ig. Therefore, B minus Ig or B minus Ig into G will be equal to Ig into R. B will be equal to Ig taken common R plus G, which gives Ig as B upon R plus capital G. B is 12, R is 11, 50, capital G is 50. So Ig comes to be 0.01 ampere. When the galvanometer is converted into voltmeter, then shunt resistance S is given as Ig into G upon I minus Ig. Values are known. Ig is 0.01, G is 50, I is 10 and Ig is 0.01. So we get shunt resistance 0.25 ohms. Next, solution to question 11. Question is, using Kirchhoff's laws, find current in 2 ohm resistor in the given circuit. This is the given circuit. We have to find the current in 2 ohm. For simplicity, suppose this is E1, this is E2, this is R1, this is R2 and this one is R3. Currents are, this is I1, this current is I2 and this current is I3. So we have to find I3, current in 2 ohm resistance. Suppose this is closed loop 1 and this is closed loop 2. Kirchhoff's voltage law in closed loop 1 gives, this is closed loop, 1 Kirchhoff's voltage law KVL, sigma EMF is equal to sigma IR. So E1 is equal to I1 R1 plus I3 into R3. Values are known. E1 is 35 is equal to R1 is 3 I1 plus I3 is I2 plus I1 plus I2. I3 is equal to I1 plus I2 from KCL at this point into R3 is 2. So 35 will be equal to 5 I1 plus 2 I2, equation 1, and KVL in closed loop 2 gives. In this closed loop, sigma EMF is equal to sigma IR, means E2 is equal to I2R2 plus I3R3. $40 is equal to R2 is 4 I2 plus R3 is 2 again I3 is I1 plus I2, which gives 40 is equal to 6 I2 or 2 I1 plus 6 I2, equation 2. Now solving equations 1 and 2, we get I1 is equal to (5 ampere), I2 is equal to 5 ampere, I2 is equal to 5 ampere. Therefore, I3 will be equal to I1 plus I2, that is 5 plus 5 is equal to 10 ampere, which will be the current in 2 ohm resistance. Next, question number 12. The question is, the driver cell of a potentiometer has EMF 2 volt and negligible internal resistance. The wire is 100 cm long and its resistance is 3 ohms. Calculate the resistance needed in series with the wire so that 5 millivolt potential difference is observed across the wire. Find the EMF of the thermocouple which has balance length of 60 cm on the potentiometer wire. Solution here given. Suppose this is potentiometer wire, potentio AB and a potential difference of and a voltage source of EMF 2 volt. and negligible internal resistance. Suppose this is E is applied across the wire. What resistance should be applied in series to make? First, length of wire, L of wire is 100 cm, resistance of wire is 3 ohm. First, R series resistance needed to produce potential difference between wire A and B, means potential difference between A and B produce VAB is equal to 5 millivolt, that is 0.005 volt. Second, E dash will be what? EMF of thermocouple if L dash is equal to 60 cm. Now solution. First, according to question, VAB is equal to, if current flowing is I, then I into RAB, which gives 0.005 volt. This gives I as 0.005 upon 3 ampere. Therefore, E will be equal to VAB plus I into R. Therefore, R will be equal to E minus VAB upon I. E minus VAB upon I. Second part, potential gradient is equal to VAB upon LAB. Therefore, E dash will be equal to VAB upon LAB into L dash, that is 5 millivolt into 60 cm upon 100 cm. cm cancels out and we get millivolt. So the EMF of thermocouple will be 3 millivolt.